Right. Question 14 here looks at the Claisen rearrangement. And I've given you, in this case, both the starting material and the product. But one of the things we learned about the Claisen rearrangement is that typically this reaction requires very high temperature, 250 degrees Celsius. And the question becomes, why does this reaction require such high temperature? And so what I want you to do here is provide a mechanism and then discuss why that mechanism helps us to understand why high temperature is needed. So before we even do that, why do we typically need high energy, high temperature for a reaction? Well, usually it stems from having a very high activation energy. And so the mechanism of this reaction, you may recall, is that it's a paracyclic reaction where the electrons shift around in a cyclic fashion like this. And then the resulting carbonyl is able to tautomerize to give the product. But it's in this intermediate where we see the reason for the high energy that's needed. Our starting material contains an aromatic ring. Our product contains an aromatic ring. But the intermediate, the ring is no longer aromatic. So during that first step, we lose aromaticity. And for a compound being aromatic adds a lot of stability to most molecules. And so in order for that first step to occur, we have to overcome this huge negative where we lose aromaticity. And the only way we can do that is by providing a lot of energy to overcome this high activation energy. So our mechanism shows us the loss of aromaticity, and that's what requires a very high activation energy.